Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Dan Hafiz bin Sulaiman, DE30304. Okay, today our group from group 2 will present about object detection in picture using YOLO and cloud computing. This is my group member, which is Yazita Ridwan, Muhammad Zamani Amni, and me, Muhammad Dan Hafiz bin Sulaiman.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zamani Amni bin Muhammad Zani. I am from Group 2, Section 1, Chow. And today I want to represent you about the flow chart we using for this project and the precision and loss in this project. Okay, first, this flow chart is shown how to train a custom image dataset using YOLO V8 in the Google Colab. Okay, we start at the first process. First process is we must download the dataset from any cloud computing database such as Google Kaggle, Open Image Dataset V7, and Google GitHub. Some of us our team is choosing to download the dataset with coding in Google Colab, and some others using Kaggle to download the data image, the dataset image. Then after we collect and initiate the custom dataset, we process the image augmentation and pre-processing, and we split the dataset into train, valid, and test set. Then we can initiate the dataset using CVAT. After we get the dataset image and its labels, we can train this dataset in YOLO and in the Google Colab. Okay. After we train YOLO V8 in Google Colab, if it say yes, then we can evaluate train models and analyze result, and it will achieve the training objective for this project. Okay, but if it uh, no objective achieved, it will looping again through the YOLO training until we get the better result. That's the flowchart for this project.
Assalamualaikum, my name is Razida Ridwan binti Razlan, and for this project we need to detect an object in a picture. We chose the horse picture as the reference. For cloud computing, we use the Kaggle website to download the picture, which is we download 218 pictures. First of all, we use CVAT website to start annotating. We use the tools provided by CVAT to create bounding boxes around the object. Then typically click and drag to define the area. After annotating, we can review our annotations for accuracy and completeness. Once satisfied, we save and export the dataset using a YOLO file to insert it into Google Drive. For Google to be able to read the dataset for the coding. In Google Drive, we prepared 3 files: test, train, and valid. And in each file, we create a new folder which contains images and labels. For the images folder, we put all the pictures that we have downloaded from Kaggle, and in the labels file, we put all the datasets that we export from the CVAT website. All this file we created to make Google Colab read the dataset clearly from testing until validation to make the result more accurate based on the coordinate or dataset that we annotated before.
I will continue for the explain on how to execute training, validating, and testing process. This is the coding that need to be done, and I just explain it with words to simplify it. Okay, the things that we use in training dataset is Google Colab and YOLO V8. The procedure for model training is by now first upload dataset to Google Drive and put in 3 different folder: valid, test and train. Number 2, create Google Colab and data YAML file in desired folder. Number 3, follow this target and put inside the data YAML file. Number 4, open Google Colab and install YOLO V8. Number 5, mounting Google Colab and choose desired location into G Drive. Number 6, check if target is successful. When the target is we get this, and we can start to train the dataset by 200 epochs. After successful train the dataset, we can see it located in the G Drive in runs folder. Number 9, we will check the prediction summary of train output. This is the output for checking the precision and loss. Number 11, this is the validate dataset process. Number 12, if you want to check the correct detection and mistake, we just using this command.
So from this picture, we can see that there are mistakes, missed detections, and correct detections. A mistake is actually when the picture of a horse cannot be detected, otherwise it will be detect another thing, such as a human or something other than horse in the picture. Misdetection is when there is another horse in the picture but it cannot be detected. Finally, correct detection means each of the horses can be detected perfectly in the picture as shown here.
We can go to the next precision and loss. We have three graph that represented the precision loss in this project. Okay, first is a precision confidence curve. We call it as a peak curve. This graph is shown is increased from 0 to 1. Accuracy on the y-axis that represent precision increase in proportion to the confidence value increase along the x-axis. Okay, this model made a fewer false positive relation. This is a false positive relation. It have a fewer of false positive relation, and it improving the detection accuracy. It is interesting to note that the graph rising direction suggests a positive correlation between confidence level and accuracy. That is a precision confidence curve. And we go to the next graph, precision recall curve. For this result, is shown a unique pattern which represents the trade-off between precision and recall. This is we call this a fall down is we call a trade-off between the precision and recall for different threshold. High precision is correlated with a low false positive rate, and high recall is correlated with a low false negative rate. An area under the curve which a high value indicates high recall and high precision. Okay, in this figure, we have a high precision progressively drop from 0 to 1 to 0, and from this we can get the model are good at reducing a false positive relation, because from this is a false positive relation, and this is we can decreasely a false positive relation which rise overall accuracy. This is the for the PR curve, and for the last is R curve. From this above, we can show an interesting pattern where the confidence curve is rise from 0 to 1, but the recall value fall from 1 to 0. Okay, this normally the recall value must begin at 0 and it will increase until it achieve 1. But in this result, we get the starting point is 0.99 and indicate they are maybe have an error. This graph have an error, and as the x-axis which represent confidence value normally will follow a standard pattern that is rising from 0 to 1. A confidence score which 0 to 1 represented the model level of confidence in its prediction. Greater confidence is indicated by the higher number. Okay, that's all from me. Thank you.
For the conclusion, Google Colab was used to write and execute arbitrary Python code through the browser utilizing CVAT for image annotation. Yellow V8 is for train, validate, and test your dataset. Kaggle was used for accessing open dataset, improving productivity and performance. CVAT was used for image classification and segmentation, improving annotation accuracy. Data reparation was done and the dataset was divided into training and testing sets. Google Colab provide free GPU resource for efficient deep learning training, and Google Drive was used for seamless data access. YOLO V8 and its dependencies were installed and the model was fine-tuned for real-time object detection. Okay, that's all from our group. Thank you.